Assalamualaikum everyone. Welcome to my YouTube channel Brain Gamer. Today we have a new video on the 8086 emulator. It's all about the introduction phase. From this video you can learn about the 8086 emulator that we used to perform our coding and other activities. So without the further ado, let's move on to the video. So the platform that we will be used for the assembly language coding is EMO 8086. I have previously installed it, and it's not a matter of a big deal to install. It's quite easy. You can just search on any browser by just writing EMO 8086, and you will get that from the internet. So after installing the EMO 8086, we will be ready for doing our coding part. So I'm clicking the logo of EMO 8086. So you will get a interface like this, and here you just need to click on the new. So after clicking the new, there will be four options. So as a beginner, today I will use the fourth option, and under that empty workspace will be preferable for now on. So clicking OK, so we can see that this page, this is a blank interface because that previously we have choose empty workspace. This is the platform where we will do our coding in assembly language. So now we'll try to move on to introduce with the features that it provides, and let's get started. So first of all, I assume that you are now um, familiar with the coding, actually the basics of the coding. Uh, so I am trying to give you an example initially, then we will break down the breakdown line by line with the demonstrations. So we know that before uh, getting onto the code, we use a semicolon. So what's the use for semicolon? Uh, in case before uh, writing a comment of a line or in a line, we use semicolon. So after giving semicolon, the things we write in that corresponding line turns into a comment. Okay, so I am just writing comment by saying that practice for the beginners. Let's see, practice for beginners. You can see that the line turns into a green colored because this whole line has turned into a comment because of using the semicolon at first. So we are now trying to do or uh, we are now trying to do some coding, starting with the very basics one. So let's start. Move x comma 1 2 3 4 h. Move vx comma 2 3 4 5 h. Add x comma bx. So what does this code do? First of all, we can see from the second line that move AX, comma 1, 2, 3, 4. It means basically we're using a move instruction here. This is a double operand instruction, and the first operand and the second operand are separated using a comma. So from here, we can see that this X is the first operand, and 1, 2, 3, 4, 8, this is the second operand. So when we are writing move instruction, suppose here we are saying that move AX, comma 1, 2, 3, 4, 8. It actually means move is a double operand instruction. Move is a double operand instruction. Here we can see two operand separated by a comma here. This is the first operand, which is working as a destination. And this is the second operand, which is working as a source. And move is a kind of data transfer instruction. Data transfer instruction. So what it does is it just copy the value from the source and then paste it to the destination. So here we can see the source has a value of 1, 2, 3, 4, and this H denotes that the number 1, 2, 3, 4 is in hexadecimal format. Okay, this is in hexadecimal format. Okay, so the data 1, 2, 3, 4 hexadecimal is stored into the AX register. So when we are just going to run this line, we would see that AX will have a value. X will have a value of 1, 2, 3, 4 hexadecimal. So if you want to know more about the instruction of move, you can see a card right now in the upper section of the video. Just click on that and you will directly move on to the detailed lecture regarding this move instruction. So what we can see that I will just make a comment on the corresponding line that the code will do. Okay, so we can see that after executing the second line, X will have a value of 1, 2, 3, 4, which is in hexadecimal format. So in the third line, we can see that the same instruction has been used, that is move. And in this case, the first operand is BX and the second operand is 2, 3, 4, 5 in hexadecimal format. So after executing the third line, we can see that the register BX will have a value of 2, 3, 4, 5 in hexadecimal format. So I am just writing this as a comment. Then in the last line, that is, I'm talking about the fourth line, we are using a add instruction here, and it is also a double operand instruction. We are using AX and BX. So what is the use of AX? We know that the word addition, what does it mean? It just sums up the number. It just sums up the number. So In case of instruction for the 8086, the instructions are in mnemonic type or symbolic type. So the word addition, we can see the first three word is denoted as add, and this is working as an instruction for 8086 for summing up the number, and this is also working as a second double operand instruction. This is also working as a double operand instruction, and here we are using the statement as add ax comma bx. These two operands are separated by a comma here, and similarly as the move instructions, this is working as a source operand, destination operand. Sorry, the first operand is working as a destination, and the second operand working as a source. So what this statement actually do is it sums up the value of ax and bx, and the resultant value gets stored in the ax register. Point to be noted that there are four general purpose register you can see on the screen. These are ax, bx, cx, and dx. All of these are 16 bits. Okay, so we will further discuss in a later video more about on the registers. So from now on, what we can see that the value of ax and bx are getting summed up and gets stored in the ax register. So we can see that ax have a value of 1, 2, 3, 4 hexa, and vx have a value of 2, 3, 4, 5 hexa. So after executing the add ax comma bx statement, we will have a new value stored in ax, and which will be the summation of ax and bx. So what is the sum of 1, 2, 3, 4 hexa and 2, 4, 2, 3, 4, 5 hexa? You can do it using the calculator. So 1, 2, 3, 4 hexa plus 2, 3, 4, 5 hexa. The resultant value is 3579 hexa. So after executing this statement, the AX register that previously contained 1, 2, 3, 4 hexadecimal number will be substituted by 3579 hexadecimal number. So in this case, I am writing the principle that add x comma bx do as a comment here. So ax value will be substituted by the summation value of ax and bx, and it will be 3579 hexa. So this is the code. Now, if we want to run this code, what should we do now? You can see that we have a tab named Emulate. So we will use this. After clicking that, we will have a two separated window in front of us. You can see one is this, and the other is known as original source code. Interestingly, if you look closely enough, the code that we write is just copied into the original source code, and the first line have a yellow colored notation. Okay, so what does it mean? We will break down step by step. So from the left side, we can see that there are some registers here. Okay, there are some register, and this is AX, BX, CX, and DX. So these four register AX, BX, CX, DX are known as general purpose register. Okay, and these are 16-bit registers. So this 16-bit register X can be divided into two segments. One is AH and another AL. AX, what does it means? A stands for accumulator and X stands for register. So AX means accumulator registers, which is, of course, as previously mentioned, 16-bit register. And these 16-bit registers are divided into two 8-bit registers, which are AH and AL. A always stands for the accumulator, and H basically denotes the higher portion, portion, and L stands for the lower one. So this AH is 8-bit register, and also the same thing goes for the L. Okay, so from the interface, this is AH and this is AL. So under this BX registers, similar type of things can be said here. This is BH and this one is BL. Similarly, this is CH, this is CL, this is DH, and this is DL. And we can see that CS, this is one kind of address register, which is known for code segment. IP means instruction pointer. SS is basically a category of segment type register. SS stands for segment register. SP known for stack pointer. BP is base pointer. SI means source index. DI means destination index. DS and ES also goes under the categorization of segment register. DS stands for data segment, and ES stands for extra segment. So now moving on the running the code. After clicking the emulate, we will see these two tabs opening in front of the screen. Now, what we should do now? You can see that there are two options here for running the code. One is single step and the another is run. If we click the run button, the whole code will be executed at once. But on the other hand, if we use the single step button, this will help us to analyze this code line by line. Okay, and if you see or the original source code interface, that's the first line is indicating as a yellow highlighter. So when we will use the single step button, the yellow highlighted line will be executed. And after that, this highlighter will move on to the next line, which means that now this line is ready for the execution after clicking the single step button. So firstly, I will demonstrate the single step part and then the run portion. So after clicking the first time the single step button, the yellow highlighted line will be executed. And as we discussed, the X register after execution of the second line will be stored 1234 hexadecimal number. So we can see that the X register consists 1234 hexadecimal number, and this the yellow highlighted line just move on to the next line. Okay, so again, if we use the single step, this yellow highlighted line will be executed, and BX register will have a value of 2345 hexadecimal number. So here it is. Now, another pressing on the single step button, what it will do that this AX value and VX value will be summed up, and X will be substituted by the summation number of these two, that is 1234 and 2345. And we can see from the screen that X will hold the number of 3579 in hexadecimal format. So let's see what happened. Okay, so we can see that the thing that we learned and that we are getting from the emulator is exactly the same. So we are getting started with our learning process. Hope we will learn many more on the upcoming videos. So there are many things to do now with this interface. Let's see how the run actually works. So we will use the emulate button, and clicking the run button, we can't have access this single line execution if we use the run button. So after clicking the run button, this whole code will be executed as a whole. So let's see. Yes, the after execution of the program, we can see that X will have a value of 3579, and BX will have a 2345 value, which is expressed in hexadecimal format. The value that we can see in this tab, that is AX have a value of 3579, BX have a 2345 value. These are all showed as hexadecimal number. It's by default. Okay, so if you want to know the format of this number into different categories, such as what is the value of the this value as a binary, so what can we do is we can just double click on any of this segment. Suppose we want to know the value of the X register, so we are clicking a double clicking this portion. We can get a extended value viewer. So from this tab, there's a first option named as what. We can access the other registers as well from this selection menu. Here are the AX, BX, CX, and other register value that we can see from here. And suppose I am selecting X, and now we can see the value of the AX value as a hexadecimal format, which is 3579. And if this number is converted into a binary one, then we can see from this binary portion. If we look at the hexadecimal value of 3579, if we want to know the of this value into a decimal one, we can see from this decimal 16-bit tab, which is categorized into two types, unsigned and signed. And we can see that this 3579 hexadecimal value is converted into a decimal one, which is expressed as 13,689 in decimal. But there's another section that we can see here is decimal 8-bit. What does this actually do? Okay, so we can see that this 18-bit, there is a 53, and the other section holds 1 to 1. What does this scenario presents? We can see that this AX register can be divided into two portions. This is for the H and this is for the L, and this consists 8-bit hexadecimal number, and same thing goes for the H as well. This 79 hexadecimal number can be also converted into a decimal one, and segment wise this is expressing in decimal format. So if I now want to give a detailed explanation on it, if we convert the 79 hexadecimal number, what does the value will hold is 121, that is 121 in decimal. That what it is showing. Similarly, the 35 hexadecimal number, if we convert this into a decimal, it will show as a 53. So actually this decimal 8-bit segment actually holding the value in a decimal format segment wise. Okay, that's why it is saying in decimal 8-bit. So if we want to analyze the BX register, just select BX from the section menu, and you can analyze this BX number as well from this extended value viewer. Okay, now moving on to the next part, we can see that there are two modes, word and byte. By selecting this word option, we can access the whole 16-bit number here and analyze it. But if we use the byte section, we can't access the 16-bit number. Interestingly, if we carefully look at the register that we are analyzing, it's BX, and we know that BX is a 16-bit number. BX is a 16-bit register actually. BX is a 16-bit register, and it can be divided into two portions, that is BH and BL. By selecting this byte option, we can access the BL, that is the lower portion of BX. Okay, lower portion of BX. So we know that if we look at the BX register holds a value of 2345, and this 45 is stored into BL, and this 23 is stored into BH. By selecting this byte mode, we can have access of BL, and this BL have a value of 45, and we can see that from here. Okay, so 45 value is in hexadecimal format. Then we can have a look of this number into another or different types of formats, such as this is the binary, this is octal, and this is for the decimals segment. I hope you understand. In 8086 emulator, we have a 16-bit flag register where we can have a look on a total of 9 registers that work for the 8086. Out of 9 register, 9 flag register actually, those can be divided into two types. One is known as status flag registers, and the other one is control register. So if want to observe the flag registers, we have to just click on this flag, and we will get a new tab here, interface, and we can look at all the flags here. The first one is identified as CF. The CF means carry flag. Then ZF, this denotes zero flag. SF means sign flag. OF means overflow flag. PF stands for parity flag. AF, auxiliary flag. 1, 2, 3, 4, 5, 6. These 6 flags as a whole are known as status flags. We will have a separate video on these flags also in experiment number 2. And there are other 3 flags for control. These are, the first one is TF, which is known as trace flag or trap flag. Next is IF, which is called as interrupt flag. Then DF, known as direction flag. These 3 flags, as discussed earlier, known as control flag. So control flag has 3 and status have 6. As a whole, this 6 plus 3 resulted as 9. The total number of flag is 9, and these 9 flags are arranged in a 16-bit register for 8086 and named as flag register. Okay, so to have a look on the flag register, we just need to click on the flags here, and we can observe the different status of the flags here at any time. Okay, then there's the stack pop-up button here. So if we click on the stack, we'll have this kind of interface. And we know if we want, we will have a separate video on the stack segment as well. And from that video, we'll have a clear understanding what actually stack segment do. Okay, so let's skip this part, but at least you know that how to observe the value of different stack segments' value. Now we want to talk on the declaration of the variables for 8086. So how do we actually declare variables? The principle actually for the declaration of the variable stands like, first of all, we need to give it a name. Then we have to give a size and then the value. Okay, then the value. So suppose we want to declare 2 variables here. One can be identified as A and the other one is B. We want to have the variable A to hold the value of 2 or 4. Suppose we want to have a value of 4 here, and B will have a value of 5. So how can we declare these 2 variables? So what does the principle look like? First, we have to give a name. So here, just we are giving it a name as A, and the size. The value that the variable A will hold is 4. Okay, is 4 in decimal. So for declaration of the size, we have different parameters such as dB, dw, and so on. This dB denotes as defined byte, and this dw can be denoted as defined word. So in case for a variable that is where the size is defined as dB, it means that this a variable can hold a value up to what? Up to 1 byte means 8 bits. So this a variable can hold up to 8-bit number. Okay. So if somehow there's a chance or possibility that the value that we want to store in A exceeded the 8-bit size, then we have to use dw. Okay, so if the number that we want to store in A have a value of more than 8 bits and less than 16 bits or equal to 16 bits, then we should use dw. Otherwise, the a variable cannot hold the exact value that we want the variable to hold. Okay, so in this case, this four decimal number can be written as 0100. So if we want to store this 4 into a variable named a, we can use db as a size. But if we do use dw, that's not an error, as that's not an error, because if we use db, its capacity is up to holding 8-bit number, and if we use dw, its capacity get extended to 16-bit number. So that's not an issue. But yes, if we are concerned about the size, then size efficiency, then we should use db. But in this case, we are neglecting the size efficiency issue and using dw. So in this case, a dw4 means this a variable can hold a value up to 16-bit number. Okay, and after giving after defining the size, we just have to give a value that we want to have the variables to hold. Then similarly, we declare a second variable named b, and it is holding a value of 5 in decimal format. Clear? Now, if we want to have a look at those variables, how to observe those, simply by click the emulate, and we will, as usual, have these two tab in opening in front of the screen. And as we have this variable declared, we just need to click on the vars tab. Here it is, and you can see here all the variables that we define in our code. And in this code, we are defining only two variables, a and b, and as a result, in this variable section, we can see these two variables. Okay, and if we go depth on this variable section, there's a option named size. Here we can see the value of a in word. Also, we can see those number in byte. Look at the value of the a. It gets changed into a 8-bit value. So we can just select their size from this size section selection panel. D word means double word. If we choose this, it will show the value that A have in 32 bits number. Okay, double word. One word means 16 bit. Double word gets multiplied 16 by 2, so it turns into 32 bit. Okay, so we can just select the size that we want to observe the corresponding variable. So I am just sticking this variable into Word. Okay, then this number can be shown in different formats as well. Suppose we need to have a look this value into a binary format. Just select the binary and just select the binary. Look, here it is. We can see this number into a binary format. Okay, if we just use the byte, then this number will show into a 8-bit binary number. I hope you understand. So from this menu, we can convert the number into a different formats. Signed and unsigned are for the decimals. Then there's our ASCII code, octal, binary, and hexa. Okay, we can see that we have a calculator option right here. This is working as a mini calculator integrated in the EMU8086 interface, and we can calculate, we can use division, multiplication, summation, and subtraction of different numbers using and find out the results of them using this mini calculator. So if we use decimal, then we have to write the numbers that we want to uh, do. We have to write those numbers that we have to write the numbers in decimal format and do the operation that we want. Okay, so if we just want to have a summation between 12 and 16, so I am writing just 12, and then the operation is addition and then 16. Okay, so this is the format, and if we just click on the enter button, you will get the result. And we can see that this 28 refers to the summation between 12 and 16. Okay, so this is how we can do summation. So if we want to do subtraction, this is how it goes. Enter, press enter for the result. Then for the multiplication, press enter for the result. Then for the division, we have to use backslash for division operation, and press enter for getting the result. Okay, this can be done in decimal format, and so for the other formats as well, such as hexa, octal, binary. So how can you do such kind of operation in hexadecimal? Just click on the hexadecimal part and write those numbers. Suppose for our convenience, say, so for our advantages, we select the two numbers that we used here in the code, which is 1, 2, 3, 4, and we will do the same addition operation between these two numbers. So 1, 2, 3, 4. This number is should be denoted at hexadecimal as we click or select on the hex mode. So to denote this number in hexa, we have to put h at the end of the number. Okay, we have to put h at the end of the number because because of defining this number as a hexa. So for the addition operation, we have to put a plus and then put the remaining number. And if we want to get the result, just put press, and here it is. And we can see that the number, the result supposed to be 3579 in hexa, and we are getting the exact result from this mini calculator integrated in the 8086 emulator. So this is useful actually, and you can do this on the other two formats as well. And you can see that under the decimal portion, you can do the same kinds of operation in signed and unsigned number. If the number is indicated as signed, you just need to check this box, and later on you have to just put the number according to the size you have selected. So this is mini calculator. Here we have a option that is called converter. This is useful to make a conversion of any number into a different format. Suppose we have a value of 1, 2, 3, 4. Okay, any number between 8 and 16 bit, but for 32 bits, 32 bits, we can't use this converter because there are only two modes accessible here, 8-bit and 16-bit. So if suppose I want to give a 16-bit number here, we can give our input in any of this section. Okay, you can give the number in octal format or binary format or decimal format or hexadecimal format. It's just the user's will, what he will do or what kind of number he will put as the input. So I am just as now on I will put a 16-bit hexa number. So I am just selecting the 16-bit, and as mentioned earlier, I am giving the number as a hexa. So in this hexa portion, I will write the number 1, 2, 3, 4. So as a result, you will instantly get this number converted into decimal, octal, and binary. So this is pretty useful actually, and you can sometimes use this feature to convert any kind of number that you want. Thank you all. This is all for today. I hope the video helps you to learn at least a little, and helps you to get familiarized with the 8086 emulator interface. This video will help you, and if you like this video, please give a click on the subscribe button, and kindly give a like also, and share within your community so that more students can enjoy this video that they may need.